So here we are back again for one more example on a video lesson. And right there's another example. This one's sort of like the polynomial we did, except it's all fractional exponents. So that's why I picked this one out. You can still find a lot of bits of information about it. 2x to the 5/3 minus 5x to the 4/3. Let's take a moment and find out what can we find from that original function. Pause for a moment and see if you can get the x-intercepts, y-intercepts, domain. Are there any asymptotes, any end behavior, that sort of thing. And to find some of this information, it really helps to factor. Once again, if you want to find those x-intercepts, factor it and see what values will make this equal to 0. Now this bit's a little trickier. You might actually have to solve that and say, gosh, if I've got that equal to 0, how can I find my x-intercept? Well, it looks like I'm going to have to cube both sides. Yes, it is that common and, of course, much loved answer, 125/8. Yeah, that's where our x-intercept is. As for the other things that are here, domain and range, it seems to me that especially since these are cube roots, you can plug in any number you want. So the domain is going to be all real numbers. As for asymptotes, this one also does not have any asymptotes. Look for rational functions if you want to see some asymptotes there. End behavior, well, I bet this is going to be going towards infinity or negative infinity. Let's see. We'll find out. If you plug infinity in, well, you just go with the highest degree. It's going to be going towards infinity or negative infinity. So we can look at that as we go. Let's take the first derivative now to get a bigger picture of this problem. Notice that once again, after we find that function or its derivative, we're going to factor it. We want to find the critical values. When I factor this, it's easy to find a common number. When you go for the common variable, look for the smaller of the two powers, the least power that can be taken out of every single term. That's going to let me know that my critical values here will be 0 or 8. If you let this factor equal 0, you'll find out that x to the 1/3 equals 2. And then if I cube both sides, I get x equals 8. I could make a sign chart here. I could find where it's increasing or decreasing and all those extrema, but I'm going to try and do that with the second derivative. Let's see how that works. Taking the second derivative, it's not too hard. I'm just using the power rule. But once again, I'm going to need the critical values of this derivative, which means I'm going to have to factor again. What common term can I factor out of the first and the second terms there? Well, for some of you that might be unexpected, but the common number isn't hard. But for the variable, remember, I'm looking at the least degree, the smaller degree of those variables, and that is negative 2/3, which is less than negative 1/3. When I factor out, that's like dividing out. It's like dividing both of these terms by x to the negative 2/3. If you don't believe me, distribute that back in and see if you get the same starting value there. But that's going to help me with the critical values. I'm not sure why, but I always enjoy saying the critical values for the second derivative. I put CC instead of C for critical. I don't know if anyone else in the world does that. It's probably just a me thing, so don't expect that. However, I made a nice sign chart around 0 and 1. I got concave down, concave down, concave up. That tells me I have an inflection point right there at 1. Not at 0, but only at 1. It didn't change concavity there. And if I want to find the y-coordinate for this, I go to the original function and plug in 1. So now I know my exact inflection point. I also want to take a look at these critical values. I have a critical value here at 0. Well, that doesn't tell me anything. At 8, I know it's concave up, meaning 8 must be one of those minimum values. Plug that into the original function to get the y-coordinate. I'll break this down a little bit more and finish it up in the next video.